Welcome to the Eonics Podcast, a podcast about software engineering, new ways of working, and lots of different interesting topics. I have one of my favorite returning guests today, Yatish Porwal. Welcome.
Thank you, Marcus. Thank you for having me.
We have already talked about many things. One of them was domain-driven design, which was received by a lot of people positively.
That's nice.
So we were thinking maybe we could tackle another architectural related topic.
Okay,
and
sure.
I know you work with something called the hexagonal architecture. Is that the correct way of pronouncing? I think so.
That's the correct way.
A hexagon is how do you say that? A six-sided polygon, or
it's a polygon, as you said, and it has 6 sides.
Like the thing from a beehive. I think that's the visual image.
That's
right?
a visual way you can say, or a benzene kind of a structure, right? The carbon,
So, I have lots of questions. What is this even about? How does this relate to programming or IT architecture?
Sure, I can talk about that. So basically, the idea behind the hexagonal architecture, as the name suggests, is that it has 6 phases. Mm-hmm. So imagine a system where you have multiple incoming requests or multiple ways where people can interact with your system from an incoming side or from the outgoing side.
Okay.
Right? So you have 6 phases. So
it's like connection points.
It's like connections, right? So so now you have that beehive kind of a structure, which is hexagon, and then you can put another hexagon on top of it on one phase, and that becomes maybe your input, and the another hexagon on the other side of it as an output.
Okay.
So it's kind of a plug and play, and all those edges that we see on the hexagon pretty much is called interface.
Okay.
So you define an interface, you expose that interface to your incoming or outgoing request, and then you are busy with your implementation, and the other team is actually taking your interface and says, like, this is my contract, this is what my input variables are input parameters, and these are my output, and that's all I care about. I don't care about any detail of the implementation.
Wait, but you mentioned a contract?
Yeah. So, I mean, in Java, we call it interface as a contract.
Okay.
So, when you are developing an architecture where you have a multi-layer architecture, like n-tier architecture, so every layer just exposes their interface, saying that, I will accept these parameters and I will respond to you in these as a response object.
It's a literal contract between the component and the other component calling it or receiving data from it.
Right. It's a contract between caller and the called party.
Right.
Or called component. Right.
Yes.
Yeah.
And so, what is different? What is specific about this hexagonal architecture? So now you explained kind of what it is, but what's the difference between a more traditional architecture?
Yeah. So what used to happen in traditional architecture or even in entire, what people do is they create one component, and then that's the caller, and then they create another component as a called, and they create a dependency between them.
Right.
So the moment you change the called implementation, that dependency also goes with the caller.
So then you have to replace that as well.
Yeah, so if there are changes, then you have to replace. So that's where this contract comes in, that you spend your time at defining your contract. Because once you have defined your contract, you have to be abiding by that.
Right.
You cannot violate that. Right? So otherwise you create another version of your contract and you say, now the previous version is older, go to the new version, etc., right?
Okay.
Yeah. So the bigger thing about this hexagonal architecture is the contract binding, and then since it's a contract binding, the caller and the called party, they are unaware of their own implementation, so it becomes more of a language agnostic.
Oh, you could even then have different parts of the hexagonal architecture in completely different
languages. Exactly.
Right.
Exactly.
As long as they abide by
the contract. One side you can have a Java, on the other side you can have a .NET.
Is the contract like an actual, how do I say this? Like, is that also actual defined in some kind of language, or like?
Yeah, that's what we call as an interface in Java.
Oh, that is the interface.
Yeah.
Okay, and then you can look up the different if you have a hexagonal architecture, you can just look up the contracts from the different components,
right?
And then implement it in your own
way.
And then why is there something specific about the 6 sites? I didn't get that.
Well, it's
or is it more like a metaphor?
It's just a metaphor, right? It can have many sides, right? I mean,
okay.
Yeah. Well, but in general, it was like, you can have multiple. The concept behind that was generally in your application or a system, you have one point of entry.
Right.
But this hexagonal allows you to have a different points as an entry point.
Okay. Yeah.
Right.
Yeah.
So that's the whole idea.
So it's a multifaceted.
It's a multifaceted, exactly. Right. So generally, when we write application, we say, okay, this is my entry point. This is where I should do all my validation. Okay. And because this is my entry point, if the validation does not pass, nobody will go inside and see what is happening.
Okay.
But when you have a multi-entry point, then you have to really think about it, where to put the validation. Right. So as I talked about in the domain-driven design, so we put all our validations in the domain.
Right.
So there are applications which are accessing that domain layer directly, so they get that validation, and there are applications which they call our API through a controller or the REST API.
Right.
So they also get the validation. Yeah. So the reason actually this hexagonal architecture came in place, especially with the big bank that I was working with, because the database layer, right? It was very tightly coupled with all the other layers, and they wanted to have another database layer. So, for example, they wanted to write into one database, but wanted to read from the another database.
Okay, yeah, I see.
Right? And they have a synchronization between those two databases behind the scene. So since the code was so tightly coupled, they can't do that. So what I have implemented, or my squad has implemented over there, is decouple all those layers. So we created an infrastructure layer separately, we created a domain layer separately, we create a service layer separately, and the application. So they are all separately and just binding with the contract. So anytime we have been told, okay, switch this database for reading, we connected another database as a connector, and boom, we are done.
So it's almost, I guess that's why the visual image of a hexagon makes sense. Like you build these individual hexagons, and then you can kind of put them together.
Right, piece them together like a puzzle, and then that's how I was talking about in the domain-driven design as well, right? You start small, and then you keep your component, and your system becomes bigger, but it's still independent.
And what is, I mean, nothing is perfect, right? In the world, there's no free lunch. So are there any drawbacks?
Well, the drawbacks, it's again just the thinking. Right, people need to really think about their contract. So
because that becomes kind of fixed, right?
Right. Then your caller party is actually dependent on that. You cannot just create a new version of it, right? So for creating a new version, you have to really think about it when you modify that, right? What are the other places it's going to impact? So that is the place where you really need to think about it. What is required from my component? And what should I deliver?
But in a way, I think it makes sense because, I mean, I cannot call myself a developer anymore, but I did a lot of system design stuff. And at least then you can talk about it in a way of just looking at the contract instead of discussing implementations and code. But just by looking at the contracts, okay, do we agree that this is actually what needs to happen between component A or B, and then everyone can kind of understand and sign off on it. And say, like, this is how it should work.
Yeah.
But leave the implementation to
Right.
to the teams, right?
Exactly.
Because a contract is just saying, I give you this parameter.
Yeah.
This is the value range. Is it something like this, right?
Yeah. I give you another example, right? So let's say you ask me, Yatish, I would like to have a cup of tea delivered from you. Right. And then I will say, okay, let's have a contract. I need sugar, I need tea leaves, I need hot water.
Right.
And then I can say, maybe a ginger or lemon and all that. And then you specify, sometime I need a ginger tea, sometime I have lemon tea.
Yeah, you give all the options that are possible.
Right. And then you don't care how I do it, right? Whether I put it on a gas or whether I take you don't care, right? At the end of the day, you get the tea.
Yeah, I think that makes a lot of sense, actually.
Yeah.
And how does it work in practice? Because, of course, in practice, a lot of stuff happens and stuff changes all the time. I mean, contracts probably in the real world are being changed sometimes.
Right.
Is the hexagonal architecture still effective, or do you get like a cascade of everything needing to be changed because one contract is changing?
No, I mean, it actually helps when the contract change, because the requirements change and situation change, right? So it is adaptable. You change the contract, you create a new version of the contract, you then decommission the old contract.
Okay.
And then you say up to certain time you can keep that contract, and then you say now we are moving to the new one. So your consumers start migrating from the old one to the new one.
So there's this whole process in place, because then all the consumers need to know when it expires, what the changes are.
Mm-hmm.
So then I guess in theory, only the consumers might need to be changed in that case, right? If a contract changes.
Yes, and consumer need to change for a reason, right? Because if there is a new contract, that means there's a new feature or a new requirement came in.
So it makes sense.
It makes sense for them.
It's not just for nothing that the change needs to happen.
Right.
And the change might be quite minimal depending on
what is asked. Yeah.
So how do you feel having worked in this architecture for a while at a big organization? Like, do you like it or?
I love it. I mean, the plug and play concept is like, I feel like, I'm in a kind of Lego land, and, I can create that and I play around with that and, put the cubes, connect in, which makes sense, right? I mean, it's not like, anyone, right? So you have to do it in an order, but yeah, it's pretty exciting one.
So you would advise other people who work in like complex...
Absolutely. It makes your components lighter, right?
Okay.
And then you have a flexibility where you can choose which one you want to implement. Today, let's say you're implementing Java. Tomorrow, Kotlin came in as a new language, and somebody says, it has a cool feature. Let's replace this component from instead of a Java, I want to do a Kotlin, right? You can pretty much do that because nobody cares, right? Which language you are
as long as you abide by the contract.
Exactly.
Yeah, that is pretty interesting.
Yeah.
Is that also actually done in practice in the organization that you've used it in? Like, are there components in different languages talking to each other with the contracts?
Yes, we are doing it, right? So in our team nowadays, different people are coming, and people are leaving and people are coming. So somebody said Kotlin has a very good feature and it's suitable for what we are developing. So let's develop some of the things in Kotlin and exploit that language for a feature.
Nice.
Right? And then we are using Scala as well. So wherever, the language supports that feature or is suitable for that feature, we use multi-language, yeah.
Okay, and now maybe I'm going to ask a very stupid question, but I hope that's allowed.
Yeah, no question is stupid, right?
How does this relate to like a microservices and those kind of things?
Yeah, so I mean, it does relate to a microservice in the sense that you can create each component as a microservices.
Each hexagon.
Exactly, right? Okay. Yeah, and then again, it will be a connector call. So you really don't need to have every code into kind of a one Java virtual environment, right? If you're using Java as a language, you can have those components running separately, and they are just connecting with the connector with the interface.
Okay.
Yeah.
Great. So I think those were my questions. What are there other topics I didn't bring up that you want to discuss about hexagonal architecture? What is a good way to get started? Maybe that's a question too.
Yeah, I mean, a good way to start is think about your component, right? And think about it like, what is the responsibility? Just like I take that example of a tea making, right? What is the responsibility? What is the outcome I want to have?
Yeah, what is the outcome I want to achieve?
Right. And then
what is the thing that's being exchanged, kind of, right?
Exchanged, exactly,
with
right.
The other components.
Right. So what is the outcome I want, and what are my input details, right? And then first you decide that, and then later on you figure it out how I want to do. So first you have to think about what needs to be done, like what functionality, what feature need to be done, and how it is going to connect with other clients. You should know your audience, and then you focus on, okay, now I need to make this component. How do I do it?
Right.
Yeah.
We actually also have an article on our website about hexagonal architecture in Java, so I will also link that in this podcast.
Yeah, that would be great. Yeah.
And there, Java actually gives specific examples of how to implement it in Java, because you've also used it in Java and in Kotlin.
Yes, yeah. It's a language agnostic, exactly. Right. It's just an architecture pattern, so it doesn't need to be any attached to any language. Yeah, right. Yeah.
Okay. Anything else we missed?
No, I think pretty much. I hope I answered all your questions.
Covered the bases.
Yeah, exactly. Yeah.
Well, thank you very much again, Yatish, for sharing your knowledge.
Thank you for having me, Marcus.
It's very generous, and I hope to talk again in the future.
Absolutely, anytime.
Okay, bye-bye.
Bye-bye.